Guys, in this video, I'm going to talk about another interesting problem. It is on LeetCode, and the problem is find the kth largest element in an array. The description says, given an integer array nums and an integer k, return the kth largest element in the array. Note that it is the kth largest element in the sorted order and not the kth distinct element, just in case if you're confused. Now, looking at the example, so the nums array for this one here, the array is 321564, and we have to return the kth largest element, which is the second largest element. So intuitively you would sort the array, and 5 and 6 would be the highest value elements, which would be towards the end of the array, and fifth is the second largest. So that's what you would do. Now, to solve this problem, you might think that you will have to sort the array, and you can opt different techniques like quick sort, merge sort, or heap sort. The time complexity for all these algorithms is n log n, so you could do that. But for me, I would just use the arrays library in Java, and I would sort the array, because the time complexity of arrays dot sort is n log n, and so it is pretty effective algorithm which is used for sorting the array. And then all I have to do is I have to return nums dot length minus k. That's all. So all looks good. Let me click run code. So yeah, it works for the case that I have against which this code was run. Let me just submit it now. So submitting works good. We got the runtime of 6 millisecond and memory is 44.7. In terms of big O, the time complexity is n log n. That's what we are going to need for the sorting, and rest there isn't anything else. The space complexity, there isn't any new space that we have used, so space remains the same. Let me submit it one more time to see if we get a better runtime. So yeah, it is in the order of 5 millisecond, and I tried submitting it in the past too, and it was in the order of 4 millisecond or so. Now, for an interview, this question seems pretty simple, but what could happen is that the interviewer might would like to understand your knowledge on all different type of sorting techniques. So you should be well aware of what all sorting algorithms are there and which one you would use if you are asked specifically to not use any library. And as I mentioned in the beginning, you could look at using quicksort or heap sort. So those could be good alternatives for you to use, because they are best in terms of the time complexity, and in case of heap sort there isn't a new space also that is needed. So you can talk about those things. So that might be something that interviewer might be interested to know when such a question is presented, which is easily solvable by writing just 2 lines of code. Now there is another option as well, other than sorting and all those things, and that is by using priority queue. Let me just paste the code. It is also mentioned in the if you go to the discuss of this particular problem. So why don't I just comment it first, the earlier solution that we just discussed. So in the alternate option, what we are doing is that we're getting a priority queue, and priority queue is uh, is like a min heap. So it will try to keep the smallest element at the front of the queue. And the intuition here is that what we would do, that for the length of this array, we would add items into the priority queue, and we would only keep the size of the priority queue uh, up to, like, it should not go above k, and the moment it happens we want to remove it. So what it would do is that it would just keep the largest element, kth and beyond. So the example that we were discussing, it would only keep two largest element in the priority queue as we keep adding, and it will remove the elements which if it goes beyond k. So, and then in the end, you are returning the first element of the priority queue, which will be the kth largest element. Now, the thing with this algorithm is that yes, it definitely gives you an opportunity to talk about another method, another data structure, and queues, like the normal queue which maintains the order of insertion versus the priority queue which is min heap type of queue. So it gives an opportunity for you to uh, showcase your knowledge about data structures and algorithms. Now, in this one, if we have to talk about the time complexity and space complexity, so space complexity is very clear. We are creating a new queue, so it is big O of order n. And then in the time complexity, so we have this one loop in which all of this is getting executed. Since priority queue is a min heap type of queue, there is a cost that we would have to pay for add and remove. Add and remove functions of priority queue are generally with time complexity log n. So what we are doing is, and then this size, this is constant time, peak is also constant time. So within the loop, what we have is we have n time complexity, and then we have log n and log n. So two log n inside the queue, the loop. So the complexity here is again n log n. So you are not gaining much in comparison to the previous algorithm that we had. In fact, you are losing the on the space side. So space could become a limitation if we are talking about a very big array. All right. So let's first run this solution as well. So this works too. I did test it before presenting it. So, and then there isn't much to pick. Between the two of the algorithms, and it might be that the test cases are not exposing the space side of issue with the second algorithm, but yeah, that's about it. Let me know if you have any questions for me, and if you prefer that I talk about any other problem, let me know and I can cover that in my next video. Thank you.